Glimpses of Modern Science, Class 8. Chapter 4. Metals and Non-Metals. Classification of elements. Lavoisier classified elements into metals and non-metals based on their physical and chemical properties. Metals are hard, lustrous, and good conductors of heat and electricity. They can be drawn into wires and beaten into sheets, example, iron, copper, silver, gold. Non-metals are generally soft, dull, and poor conductors, example, sulfur, phosphorus, carbon, silicon. Some elements show properties of both metals and non-metals. These are called metalloids, example, arsenic, antimony, bismuth. Elements like silver, gold, and platinum that occur free in nature are called noble metals. Occurrence of metals. Most metals occur in combined state. This is why they do not occur in the earth in their pure state. They occur in the form of their compounds such as chlorides, sulfides, oxides and carbonates. Some metals such as gold, silver, platinum and mercury occur in free state also due to their least chemical reactivity. General properties of metal. Physical properties of metals. 1. Metallic luster. Shiny appearance making metals attractive, used in jewelry and mirrors. 2. Color. Mostly silver or gray, gold is yellow, copper reddish-brown. 3. Hardness. Generally hard, though sodium and potassium are soft. 4. Malleability. Can be beaten into thin sheets, example, aluminium foil. 5. Ductility. Can be drawn into wires, example, copper, aluminium. 6. Conduction. Good conductors of heat and electricity, silver and copper are best. 7. Sonorous. Produce ringing sound when struck, used in bells and musical instruments. 8. Strength. Metals like iron are strong for construction. 9. State. Solid at room temperature except mercury, which is liquid. 10. Melting and boiling points. Generally high. 11. Tensile strength. Can be stretched without breaking, example, tungsten. Chemical properties of metals. 1. Formation of oxide. Metals react with oxygen to form metal oxides. Example, 2 Mg plus O2 equals 2 MgO. 2. Reaction with air. Metals like potassium react vigorously forming oxides. Example, 4K plus O2 equals 2K2O. 3. Reaction with water. A. Violent. Sodium reacts violently. 2Na plus 2H2O equals 2NaOH plus H2. B. Mild. Magnesium reacts slowly with hot water. Mg plus 2H2O equals magnesium hydroxide plus H2. C. No reaction. Copper does not react with water. 4. Reaction with acids. A. Magnesium reacts vigorously with HCl forming magnesium chloride and hydrogen. Mg plus 2HCl equals magnesium chloride plus H2. B. Aluminium reacts mildly due to oxide layer but then rapidly reacts. C. Magnesium reacts with sulfuric acid. Mg plus hydrogen sulfate equals magnesium sulfate plus H2. 5. Displacement reactions. A. Iron displaces copper. Fe plus copper 2 sulfate equals iron 2 sulfate plus Cu. B. Magnesium displaces copper. Mg plus copper 2 sulfate equals magnesium sulfate plus Cu. C. Zinc displaces copper. Zinc plus copper 2 sulfate equals zinc sulfate plus Cu. Sodium, Na. Reaction and results. 1. With air, it burns vigorously to form oxide. 4Na plus O equals 2 sodium oxide. 2. With water. Violent reaction displacing H from cold water. 2Na plus 2 hydrogen oxide equals 2 NaOH plus H. 3. With acid. Violent reaction producing hydrogen. 2Na+2 HCl equals 2 sodium chloride plus H. magnesium, Mg, and aluminium, Al. Reaction and results. 1. With air, they burn to form oxides. 2 Mg plus O equals 2 MgO. 4 Al plus 3O equals 2 aluminium oxide. 2. With water, they displace H from cold water but more vigorously on heating. Mg plus hydrogen oxide equals magnesium oxide plus H. 3. With acid, steady reaction. Mg plus 2HCl equals magnesium chloride plus H. Mg plus hydrogen sulfate equals magnesium sulfate plus H. Zinc, Zn, and iron, Fe. Reaction and results. 1. With air, they burn to form oxides. 2 Zn plus O equals 2 ZnO. 2. With water, they do not displace H from cold water but displace H on heating strongly or with steam. 3 Fe plus 4 hydrogen oxide equals FeO plus 4H. 3. With acid, steady reaction producing hydrogen gas. Zn plus hydrogen sulfate equals zinc sulfate plus H. Copper, Cu, and silver, Ag. Reaction and results. 1. With air, they do not burn but a layer of oxide is formed on the surface. 2. With water, no reaction with cold water and steam. 3. With acid, no reaction. Gold, Au. 1. With air, it does not burn. No layer of oxide is formed. 2. With water, no reaction. 3. With acid, no reaction. Classifications of metals. 1. Ferrous metals, iron, steel. 2. Non-ferrous metals, heavy metals. Pb, Hg, Cu, Ag, Au. Point. Light metals. K, Na, Mg, Al. Protective metals. Cr, Ni, Zn, Sn. Noble metals. Au, Ag, Pt. Rare metals. Li, Be, Sr. Radioactive metals. Ra, U, Th. General properties of nonmetals. Physical properties of nonmetals. 1. Luster. Nonmetals are dull and do not reflect light. 2. Color. Many colors. Examples: sulfur, yellow, chlorine, yellow-green, phosphorus, red or white. 3. Hardness. Generally soft, except diamond, which is very hard. 4. Malleability. Nonmetals are brittle, break when hammered. 5. Ductility. Not ductile, cannot be drawn into wires. 6. Conduction. Poor conductors of heat and electricity, except graphite. 7. Sonorous. Nonmetals are not sonorous. 8. Strength. Weak materials compared to metals. 9. States. Exist in solids, liquids, example, bromine, and gases, example, oxygen. 10. Melting point. Generally low melting and boiling points. 11. Density. Low densities, though iodine is an exception. Exceptions include mercury, liquid metal, sodium and potassium, soft metals, iodine, dense nonmetal, diamond, hardest nonmetal, and graphite, conductive nonmetal. Chemical properties of nonmetals. 1. Reaction with oxygen. Nonmetals form acidic or neutral oxides. Example: S plus O2 equals SO2. C plus O2 equals CO2. 2. Reaction with water. Nonmetals generally do not react with water. Exception: fluorine reacts with water producing HF and oxygen. 3. Reaction with acids. Nonmetals usually do not react with acids. 4. Reaction with hydrogen. Nonmetals react to form covalent hydrides. Example: H2 plus Cl2 equals 2HCl, N2 plus 3H2 equals 2NH3. 5. Reaction with chlorine. Nonmetals form covalent chlorides. Example: 2H2 plus Cl2 equals 2HCl, 4P plus 6Cl2 equals 4 phosphorus trichloride. Uses of common metals. 1. Uses of iron. 1. Pig iron is used to make pipes, cylinders, sinks, railings, and storage tanks. 2. Wrought iron is used for nails, bolts, wire nets, chains, and agricultural tools. 3. Steel. Iron with 0.5 to 1.5% carbon is used in buildings, bridges, railway lines, and ships. Stainless steel makes knives and utensils. 2. Uses of aluminium. 1. Used in cooking utensils and electric conductors. 2. Aluminium foil is for food packing. 3. Aluminium powder helps prevent rust in paint. 4. Light, strong aluminium alloys are used in car and aircraft parts. 3. Uses of zinc. 1. Used in dry cells. 2. Makes useful alloys like brass, copper plus zinc. 3. Coats iron sheets to prevent rust. Uses of some non-metals. 1. Graphite. Used as lubricant and in electrodes for dry cells and electric arcs. 2. Silicon. Used in electronics to make transistors, solar cells, microchips, waterproof clothes, and insulating materials. 3. Phosphorus. Used in matchboxes, fireworks, and phosphatic fertilizers. Corrosion is the oxidation of metals under normal atmospheric conditions, causing metals to waste away layer by reacting with oxygen, moisture, and gases to form oxides, hydroxides, or carbonates. It causes severe economic loss and accidents due to deterioration of bridges, vehicles, and buildings. Moist air accelerates corrosion. Factors responsible: oxygen in air, moisture presence. Examples: 1. Rusting of iron forming hydrated ferric oxide, iron 3 oxide, XH2O. 2. Aluminium forms a protective aluminium oxide. 3. Copper forms green copper carbonate, CuCO3. 4. Silver reacts with hydrogen sulfide, H2S, making black silver sulfide. Corrosion-resistant metals. Gold and titanium resist corrosion. Gold remains untarnished, titanium forms lasting, protective oxides. Prevention methods. 1. Paint coating to block air and moisture. 2. Grease or oil application prevents exposure. 3. Coating with non-corrosive metals. Galvanization, zinc coating on iron. Electroplating with tin or chromium. 4. Anodizing aluminium, forms protective oxide by electrolysis. 5. Alloying metals, example, stainless steel, to increase corrosion resistance.